Okay. Okay, let me share my screen. Okay, I think in the last class we have finished a model in private and export to Tekla Structural Designer, right? So this is a model, right? So today I'm going to apply the loadings, right? Loadings and do the analysis. Okay. So let's see flow by flow, right? This one, story 2, story 3. Okay, we can see here also. So we can see the levels, right? Base is a story 1, right? Then story 2, story 3, story 4. Okay, so let's see the foundation. So this is a base level. Okay, so this is story 2. ST1 is called story 2. Okay, story 2, story 3, story 4, 5, and roof. Also upper roof. Okay. Okay. Loading, already you know how to apply, right? Right. This is office building. So I am going to apply the 5 kPa live load and 2.7 kPa STL. Okay. So under the loading case, right? So you see self height, right? This automatic software calculate. Self height also automatically calculate. Dead load. Okay. Generally, if you have the finishers or if you have the wall loading, then you can apply under dead load. If you have a services, that means many services, then you can apply under services, right? Sometimes some people they apply to or as debt and services together. That's also correct, right? It's up to you to decide. Nothing is wrong. Okay, import load is live load. Okay, so here what I am going to do is dead load, right? I am taking as a 1.25 kPa dead load. That means 50 thick screeds, right? Plus 1 kPa for the partition. Right? Because office building, based on the code, we had allow at least 1 kPa partition load. So I'm going to apply all together 2.25 kPa as a dead load. Then services I am going to apply as a zero point 0.5 kPa. That services only allow for MNEs, the light and fans. So mine MNE, it's not a major MNEs. Right? Mine MNE, so I'm going to apply 5.5 kPa. Right? And then import load, I'm going to apply 5 kPa. Right? So you can reduce it. Actually, office building, you can go 3 or 4 kPa. It's up to you. It's based on the code. You can refer the easy one. So there's a different category. But I am going for the open office. So I apply slightly higher 5 kPa loading. Okay. So let's go to the loading, right? So all slab is the same loading. So you can use either slab loading or area loading, right? So if you select the area loading, you got to apply each slab. If you select the slab, then you got to apply the one type of the slab as the same loading, right? So uh, uh, I am going to use the area load. You can use a slab load also. So you see, now I can select the different various slabs, right? If you have a different zone, then you can divide the slab and apply the different loads, right? So it's a dead load. How much I want to apply? 2.25 kPa. Okay. So I apply it. Based on your project's loading, you can change the loading. But if you want to change the loading, you have to divide the slab. Otherwise, you have to apply as a patch load. Actually, it's not good idea to apply the patch load. So if you want to apply the different loading, then divide the slab. For example, this small portion, you want to apply the different loading. Let's say this small portion, you want to apply different loading. Then you divide the slab here. This one slab, this slab, another slab. Then apply different loading on this slab. Okay. So I had to apply here also. So I apply here. Okay. Then service load. I apply the 0.5 kPa, zero point 0.5. Same, I take the same area loads and apply the 0.5 kPa. Make sure that you apply the whole slab. If you use a slab loading, then it's okay because one type of the slab is take as a one loading. So just one click you can apply it. But if you select the area load, then you got to careful. You got to apply all the slab. Okay, let's go to import load. Similarly, I use area loads 5 kPa. Okay. For your assignment, you can use a same loading condition or you can use a different condition, never mind. So you just define, okay, what is the usage of your building, school building, office or whatever. Then you apply the appropriate loading. You don't need to follow exactly according to my loading conditions. You can change your own loading condition based on your own assumption. Okay. So now second story is done. Okay. Then I am going to go to the story. Okay. Before that, I am going to apply some line loads. Okay. So why I am going to apply the line load is a normally building right outside we have the cladding or we have the facade, right? Then we had applied the line or we had the brick walls, right? So we had applied that one as a line loads. Okay. So I'm going to apply the line load on the perimeter beams. Okay. Perimeter beam as a line load. Okay. So this line load also dead load, right? It's a dead load, right? So I'm going to apply the line load as a dead load, right? So how much we can apply? Okay. Uh, what's the floor to floor height? Let me see. It's a 4 meter height, right? Okay, let's say brick wall, right? Right, I assume brick wall, 100 mm thick brick wall, right? So it's around 2.4 kPa. I can take 2.4 kPa or 2.2 kPa. It's depends on the weight of the brick, right? It's varying, right? Some countries they we use a heavy, heavy brick. Some countries they use a lighter brick. I think in Sri Lanka mostly use 18 kilonewton per meter cube brick, right? Then so 125, including plastic 125. So it's approximately 2.2 to 2.4 kPa in the vertical elevation, right? Okay, so it's a 4 meter height, right? So I assume 2.2 kPa or 2 kPa, 2 kPa into 4 into 8 kilonewton, right? 8 kilonewton per meter. So I take 8 kilometer, but you can calculate exactly. Actually, I am doing the approximation because you see 4 meter is floor to floor height between slab to slab, right? But below your wall, you stop below the wall beam, right? You can reduce a beam depth and apply it. If in your project, you can do your own. You can calculate exactly and apply it. But for easy purpose, I use simple calculation and apply it, right? So now. Okay, click on the beam, right? So if you click on the beam, so it's automatically apply. Pick the load location, right? Member load 8 kilonewton. It's not applied. Give me a minute. Why? Sorry, it's already applied. Sorry. Can you see? And the full loads. See here. Okay. So I apply here now. 8. Right. Oh, load already applied. Actually, I don't know why I couldn't select the loads. Let me see. Why I cannot select the loads. In my mind. We do it first. Uh, Okay, I'm going to apply all around the building. Right. So this one, this one, this one, and this one, this one. Okay. Okay. So now second story already done. Okay. Normally when you bring this cursor, right, you can able to, you see the area load, right, we can select, right. Similarly, we can select the line load. But here I don't know why I couldn't select the line load. Normally we can able to select. Okay. Never mind. Okay. Second story done, right? Similarly, I'm going to apply the third story and other stories, right? So, okay, before apply, right, I'm going to verify the model if there are any error or not. I verify first, right? If no error, then we can proceed the same thing. Okay. So we validate the model, right? So go and see the error. So there's error. So what's the error? Isolated wall defined with dimensions of the column. See there, isolated wall defined with the dimension of a column. Right? That means we define the wall, but actually the dimensions look like column. So let's see what is a wall. Okay, this is a wall, right? So there's a wall. Okay, this wall, right? On the plan, this one, this is a wall, right? Okay, so you know, right? Wall means the length over width ratio or the length over thickness ratio should be more than 4. Less than 4 considers as be column. But here this length is I think less than 4 times. That's why is giving this warning. This is supposed to be a beam. It's not a wall. To me, because we are going to define as a one group wall, right? Then we can ignore this one because this one can be either wall or column. Shouldn't be an issue, right? So I think it shouldn't be a problem, right? So we can ignore it. But if you have any other warning, you should consider. But this is, I think, not a major problem. If you want, you can change this one as a column also. Right? It's not a problem. You can delete and change it as a column, right? If you change the column, then it won't give any warning. Right, then fine, there's no any other warning or error, so it's okay. So now let's move on, right? So the story. So I'm going to apply the same thing. Services slot 0.5. Mm, that lot 2.25. And import slot 5. Okay. Then I apply line load. Line load 8 kilometer per meter. Okay. Similar loading, I'm going to apply the all floors. Area services import slot 5. Services 0.5. Okay. Then it's a UDL load. Okay. First story finish. Fifth story. That lot 0.25. UDL 8. Okay. Then services 0.5. Import slot 5. Yeah. So last one roof. Oh, so import slot applied. Okay. Last one roof. That lot. I'm going to apply same. Actually, you can change it. Roof, you don't need any partitions, but in roof, you normally you need additional thickness of screed, normally we allow at least 100 mm thick because you need a slope to fold the flow, right? To water to pass through it. So normally we allow 100. So 100 means 2.5 kPa. So I apply 2.5. Right. Okay. Services apply the same 0.5. Then we have a live load 5 kPa. Okay, then upper roof, right? Upper roof basically is a maintenance, right? So we don't need a heavy load, right? So that load I as apply point maybe 1.25 50 mm straight. Then I apply the imposed load as a 1.5 kPa as a maintenance load. Okay. Okay. Loading almost done, right? Then what we want to do is we had okay now all the gravity load applied, right? We had applied the wind loads, right? To apply wind load I go to 3D mode, right? Okay. So first what I want to do is I want to add the load cases, right? So I add the load case. Okay. So wind X and wind Y. In sorry. Okay. Okay. So now I select wind X. Uh, okay. Mm, mm. Give me a minute. I don't understand why will not active. I close and open again. Okay, I don't understand why win load not active. Anyway, we run first this model, then we write to apply the win load. First, I run this model, right? And just run this model. So I think okay, it's only run. Only this one is error. There's no errors, right? So now go and see win load. Okay, I think okay. Now I can apply. Sometimes software gives this kind of issues. Okay. Okay. So now you know how to apply a simple win load, right? So create a simple window. So from here to here, I specify the width. You can specify the width of the building, right? And insert the labels, right? So before that, let me see which are the levels I have it. So I want to see the levels, uncircle levels. So 20, 23, 20, 16, 12, 8, 4. Okay. So for the loads, index, simple will load from here to here. Then add this one 20, 16, 12, 12, 8, 4, and 0. Right? Area allowed, right? I just assume 0.75 road. You can calculate and apply it. Okay. Okay. Now I go win Y, right? So simple win, select the point from here to here. Similarly, at the level 20, 16, 12, 8, 4, 0. So 0.75. Okay. So now will load also applied, right? Will load X and Y. Okay. Okay. So go and do the analysis. Okay. Analysis done, right? So we go to review menu or results menu. We can see the results, right? So for example, if you want to see the bending moment diagram, right? So click on the 1D results, bending major bending moment. Then you can see the bending moments, right? This one you already know, right? How to take this bending moment diagram. Give me a minute. Hello. Hello. Yes. 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 சரி 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 பிரச்சனை இல்லை நான் எல்லாரும் கிளாஸ்ல இருக்கிறேன் கிளாஸ் முடிஞ்சா அப்புறம் அடிக்கட்டேன் சரி ஓகே 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 sorry. Uh, okay. So you know how to see the bending moment diagram, right? Last time you already learned. Similarly, you can see the CF also, right? Right. So okay. Now we are going to design it, but before that, if you want to verify, you can see the bending moment diagram. You see here, right? This one, this edge, I didn't make it pin. That's why you can see the hooking moment. But in actual design, normally I make it pin here, right? Pin it. The edge, I make it pin. Then you don't see any cooking moment here. Okay, so it's based on your condition, right? In my condition, I didn't make it pin. That's why I can see the cooking moment there. Okay, otherwise, if you make it pin, then I should not see the bending moments here. If I see there's some errors, then you go back and review your results. Okay. Okay. Um, okay. Before go to the design, I'm going to do one more thing. I want to create a load envelope, right? I have load cases, but I want to create the envelope. So I create the envelope. This one I call structure envelope. So I call str, right? So under structure, right? I'm going to select all the structural combinations. Here, it's all structural combinations, right? Geotechnical, I want to create a geotechnical load combination. So I create first. So for generate geo, select geo. Next, next. Okay. So now I'm going to create the geo envelope also. I cannot see geo combinations. I think I have to run it. So I cannot see. Okay. Okay. Combination. Okay. So I run again. Okay. So go to results envelope. Okay. I go to results. Results. Okay. Major moment. Okay. So you can see the moment results here, right? If you want to see one element, just right click on the element and go to open load analysis view, then you can see the minimum diagram for the particular peak, right? If you want to verify it, you can see here. See here, this moment is very huge, right? 1500 kilometer meter is transferring to the column, right? If you don't want to transfer this moment to the column, then you can make it pin, right? You can decide whether you want to transfer or not, right? So I leave it first, okay? Okay, now let's do the design. Let's do the design and see we want to change the member sizes. First thing, when I see here, I already know there's some issues, right? If you see the result, then you can notice it. You see these deflections were high, right? It's very high, right? 66 is very high, right? Anyway, we go and do the rebar design and see. Okay. So for design, right? Design menu, results design. Okay. So now we are going to do the concrete design, right? Concrete static. Okay. So just click concrete static. Wait for a while. It's do the design for all the element, all concrete element. So I once shot all design all element, and then we go and review which element failed or which element we had to resize it. Okay, today class I stop around 10:15. After that, if you have any doubts, any question, you can ask me. Okay, so now it gives the review, right? So basically, green color means this one okay, no issue. Yellow color means there's some warning, but then we had to clear the warning. But red color means fail, so it doesn't work. Something not correct. So let's go and see this view, right? So we got the interactive design, right? Okay, this one is fail. Why fail? Let's see why fail. Deflection check fail. You see, deflection check fail, right? Okay, one thing you have to take note: this software do the check based on the code LOD method. It's not actual deflection method. So actual deflection method means is input the rebar and do the analysis, fine element analysis or frame analysis and check the deflection, actual deflection. But this software does not do that kind of analysis. Actually check based on the code. LOD is limiting the LOD. Okay. So if you want to make it work this one, right? What you can do is you can increase the tension bar or compression bar. Okay. So let me increase the compression bar. That means that number three, right? So I increase in the number three. Let's say I increase to six numbers of X20, right? Now it's supposed to work. Let's see. Longitudinal bar two, longitudinal bar two, bottom two. 12, 13, okay. 7, 8, okay. Okay, now you see, after I increase the rebar, bottom rebar, it's already work, right? Okay. So by increasing tension bar or compression bar, you can make it work the deflection, right? So this is one way to you can make it work, is correct, right? Another way is you had to revise the member sizes, right? Okay. So now you had to review it. Let's see, my beam size is 750 by 600, but you see how much rebar I had to provide here. For example, this one is a critical, right? We see high moment, right? So 20 numbers of H25. So which is equivalent to how many percent? Let me see. 20 numbers of H25 by 750 by 600. It's around 2.2% rebar. So it's quite heavy rebar, right? So it's up to you to decide whether you want to go ahead or you had to revise the members. Now you know how to do the design, right? So you had to decide whether you are happy with the member sizes and rebar, or there's no fixed answer. Some design you had to optimize your rebar. Some design you suppose to optimize the member sizes. We need a high headroom, or we need to reduce the overall building height, or we had to reduce the dead weight, then we can serve on the foundation. So the design, there's no fixed answer, right? So it's depend the cases. Then you have to decide whether this member size is correct or not, right? So I'm going to leave it because the all designs are satisfied, right? So even though rebar is heavy, I leave it, right? So now it's workable. So I leave it first. Um, this rebar also quite close. So I changed this one to 25. Okay. Now it's my beam is working. Okay. Why is still so red? Not updated. So I changed something here only. I think so. Okay. Okay. Similarly, this beam I can do the same changes. Okay. Let's see what's the warning here. Why warning? Okay. So warning, go to the check, see why warning. Launch the bar limit check. Okay. Maximum allowed center to center bar in the region 162. So basically we had to increase the number of bars. Okay. So increase the number of bars. Okay. So it's okay now. These are also similar. These are also same. Topa. Okay. I, okay. So basically all beams are okay. This is a beam of this also beam. This beam. My volume. All okay, right? Oh, cylinder beam. See, sometime right, it skips a warning like this. This one you had to verify it. Uh, right, this giving as a cylinder beam, right? So you had to verify whether it's correct or not. Right, I leave it first. Right, if you want to change, you had to change the sizes, and you don't see this warning, right? I think this is also same thing, cylinder beam. Yes. Okay. Okay. So basically, we already design all members, right? The second story. Similarly, other floors I can design, but I don't want to spend the time here, right? So let me go and see the columns, right? So column I see in the 3D, right? 3D. So let's see the columns. Any issue on? So basically, columns all are okay. And we can click one column and see the river, right? So what's the how much river they provide? One, how many bars? 1, 2, 3, 4, 5, 10, 16, 16 is 20 bar. Okay, not bad. 700 by 700 column. 16 x 20, not bad, right? Okay. Then let's see the walls, right? This side wall all okay. Yes. Any red color? Oh, okay. Here is a one wall showing red. Let's see this wall. Why? Power provided. Oiler buckling fail. Why fail? Hmm. Okay. Anybody understand why it's fail? Sometimes when we have a wall, right, we have this kind of the issue. So anybody know what's the issue actually? Why showing error or why showing fail? Let's see this wall on the plan. Oh, yeah, not this side. Okay, this wall. So on the plan, basically this second story, the storyboard here. This wall showing as a fail. Second story, all right, am I right? Then how comes a second story okay? The story on what fail? Anybody have any idea? You should understand. Otherwise, it's very hard to find out these errors. Okay, I saw it. Okay, so when you look at the column of beam design, column or wall design, right? The Eurocode, right, is calculate the effective length, right? So look at this wall, particular wall, is calculate the effective length is 5.6 meter, right? It's around 5.6 meter. Then is calculate the Euler buckling load, right? Based on the effective length, is calculate the Euler buckling load. You see, this is actually is a critical load. We call it as a critical load, right? This one depend only geometry of the our wall, right? You see, pi square is a constant 10, right? E is a young modulus of concrete, right? Then I over L naught, right? So L naught is effective length, I is a circumambulation of area, right? So basically, it's depend on the material and geometry of the section. It not depend on the loading, right? So let's say your buckling length is very high, then it's likely to fail due to buckling, right? Okay. So now, what's the problem is happening here? This whole wall, right, take as a one piece of wall and calculate the effective length. That's why when you see here, right, go to check, right, effective length, right, is calculate how much effective length is calculate. You see unrestrained length is 18.75 meter. It's full height, it's take full height. Okay, so now how to solve this problem? Any idea? Okay, one way you can solve this problem, right? You can change the effective length of this ball, right? So if you allow to change it, right click, edit ball, I think edit ball. Slenderness criteria. Restrain. Let me see. You can change the effective length of this wall. Okay, and the slenderness you can change as a brace wall. This is a brace wall. Yes, it automatically change the effect length. Why is it not showing? Hmm. Mhm. Last time they allowed to change the effective length. Now it's not allowed to change the effective length. Hmm. Okay. Otherwise, what we can do is we can divide this wall each floor, right? Then we can solve the problem. You say this wall, right? We don't get a problem, right? Similarly, if we divide as a one interior wall each floor, then we don't get this problem. If we face this kind of the problem, then you row the wall one by one, then you don't face the problem. The last time, previous version, actually we changed the effect length. We can ask software to take the effect length between floor to floor, so does not affect it. This version, I think they remove it, so cannot see. Okay. So other than that, any other problem? No, right? Other words all are okay, right? Right. Hmm. Okay. Okay. So if everything okay, then what I can do is I can export these results, right? You know how to export it, right? Okay. So the story also same. Story, if story, if, okay. So basically, how to solve this problem. I actually already solved at the second story, so similar problem here. So we can solve this problem, right? So after review this one, right, we can export these results, right? You know how to do it, right? Last time we learned, right? So go to report, not report, design exports. Hmm, okay, so you can export as a beam schedule, column schedule, board schedule, or drawings, general arrangement, or you can create your foundation plan and so on, right? So we know how to do. So next class I export it. So now what I'm going to do is I'm going to do the foundation design. Quickly I cover the foundation design. Okay. The last time the practice class, right? I had covered the fat footing, right? Fat footing and straight footing. Today I'm going to cover raft footing because it's a big building, right? So I'm going to consider as a raft, right? So I'm going to model the raft and analyze with the raft. Okay. So I serve this model first. Okay, raft we had to row at the foundation level, right? Okay, so this is our floor plate, right? These are the column, right? So what I decide is my extension of the raft from the center of the grid is 2 meter or 1.5 meter. So I decide 2 meter. So all around I will need a 2 meter. So I'm going to go row the construction line first. So go to the model, I row the construction line, right? Quick parallel. From here, I want 2 meter. Have to 2 meter. Okay. Similarly, from here, 2 meter. From this line, 2 meter. Oh, this line I take is smaller, maybe 1 meter. Actually, you can extra edit this one if you want. We can extend like this. This is our construction line. So this is another wall, right? So I need one parallel line here. This one also I make it 1 meter only. Okay, then this side 2 meter. And this side. This is a wall, right? So this side 2 meter or 1.5 meter. Now I setting up my outer line to row the raft. Okay. So my rough going to be this thick plate, right? So this is a rough outline. So to do the rough, right, we had to go to the foundation, right? So go to foundation. So here you see this is a matte footing, right? So there's a various type, right? So I go with the rectangular one. Okay, click rectangular one. Create the matte footing. Define area. Okay, okay, we can do like this. Easy. Sorry, sorry. Area. Oh, sorry. Okay. So matte footing is like a slab, right? One full slab, right? So now we had to set the property for the mat. So thickness, right? I choose it 800 deep, right? Later we review the analysis, right? Then we go to the soil parameters, right? Safe bearing pressure, right? So two, we had to set up two base safe bearing, one for structure, another for geo. Geo, right? I choose 200, 250 kPa, right? So structure normally three times more, right? So I make it 750, right? Then the stiffness, right? Okay, this one is you can set any values, right? Basically, sorry, stiffness means you can see the unit, right? Kilogram per meter square per meter. This one kilogram per meter square, right? So this one means, right, how much deformation you want to allow, right? For example, you want to allow maximum 25 kilonewton, right? So 25 mm, then you divide 250 divided by 225, right? Then it's become 10,000. So basically, this value depend on your allowable bearing pressure and how much is allowable settlement, right? That is called as a stiffness. Okay, okay, fine. So now we already wrote this one, right? So we can go on to the analysis. Okay, we made one mistake. I saw you. I then you can understand. Okay, now let's go and see the results. You will surprise. Okay, to see the results, right? We had to go to 2D results, right? I choose geo combination, right? 2D results. So first I see the bearing pressure, right? Uh, I cannot see this a moment. I cannot see bearing pressure. You see, these are moment are zero. It's look unrealistic, right? Why it's like this? Because you see, there's a support. We did not remove the support. Below the column, there's a support. We didn't remove the support, so That's why there's no moment, right? So we remove the supports on the columns. What we can do is here, right? So before do the analysis, we must remove the support. Otherwise, software takes the support, so you don't receive any results on the raw footing design. Okay, all columns are okay. Now is wall. Wall, I think already removed. Let me see. Walls already removed. Okay, go on do the analysis. So now you can see the bending moment diagram, right? I select the top, right? So I select the bottom, then you can see, right? Bottom. Why the next one? Okay. Similarly, you can see the combination, any combination, geo combination or structural combination. You can verify it, right? So if you want to verify the bearing pressure, right? So you have to verify for the geo combination. Select the geo combination, go to the bearing pressure. Now you see how much is maximum, 225, 227, right? We have allowable is 250, so it's within the limit. Okay, so you can check one by one. You see each combination, you can check one by one, right? So basically, you can make sure that there is no any stress exceeding 250 kPa. Similarly, there should not be any tensor. So there should not be any negative value. So if we don't have any negative, if we have the negative, then you got to readjust your raw footing. Okay, so now no be negative, so shouldn't be issue. Okay, this is the way we do the raw footing design. So basically, you have to make sure that bearing pressures are okay first. Then you have to check the bending moment diagram and do the design like a flat slab. Last time I explained how to do the flat slab design, right? So you can use either point element method using this moment, or you can draw the strip and do the strip design, right? So it's up to you to decide. So both way is correct. You can see MX, MY, right? Then you can your own design, right? It's a flat slab design, sorry, rough design, same as a flat slab. Okay. Anything else I wanted to cover in rough foundation? Okay, if you want to see deflection, right? You can see the deflection also here. Deflection here, right? So deflection basically I had to see set deflection how much, right? So you see how much this one, 222 22.7, right? How much is pressure? 227, right? So divide by this one, right? I given the stiffness, right? How much? 10,000. It should be safe, correct? Bearing pressure divided by settlement should equal to stiffness of the soil, right? So it's basically depend on the deflection, how much deflection you want to allow it. Okay, if we change, okay, let's say if I reduce it, right, 5,000, right, then you get double of this settlement. Understand? Okay, so basically you have to review whether your deflection is correct or bearing pressure, but both are correlated. Okay. Uh, okay. I think that's all my building, right? Next week, what I'm going, so next class, the Thursday, I'm going to export this result to Revit. Then we start to do the detailing. So I think this is my final class for the design, right? I don't come back for the design anymore. Right? My design is finished. Next week, I export all results to Revit. Then I start to do the construction drawing in Revit. Revit, we already have the model, right? We already done it. Then I start to do the 10-second drawings. How to basically I'm going to explain how to prepare the 2D drawing from 3D model, right? So because by end of the day we are going to deliver 2D drawings, right? So I'm going to explain how to prepare 2D drawing from this 3D model, right? So I think we have 2 more weeks, right? So these two more weeks I am going to cover this drawing preparations. Okay. So if you have any question, you can ask me. If you don't understand any design things, then you can raise up. I think this is the last design class, so it is an opportunity for you to ask any doubts on the design. Okay, I stop sharing. I stop.